Hello, everyone. My name is Chuck Long, and welcome to Inside Extreme's Fabric Connect and its simplification of the network. We'll be delivering the session in two parts today. First, I'll provide a quick overview, then hand it over to my colleague, Jake Cook. Jake will take us to the whiteboard for a little deeper dive into this game-changing technology called Fabric Connect. Our very first production Fabric Connect customer was the city of Milwaukee, way back in 2011, and you can hear more about their experiences in a separate breakout session. You know, it's always great to hear things from the customer's perspective, so please be sure to check it out. We've literally helped transform thousands of customers since 2011 in every vertical market on every continent, from small to very large implementations. Everyone benefits from simplifying the network and a model supporting a much faster time to service and time to repair that's built with security in the forefront. You know, we've hosted many public hackathon events and even offered a $10,000 reward to anyone that can hack it, but no one's cashed a check yet. So where does it fit? Fabric Connect can extend from your data centers all the way to the wiring closets and all the places in between. We can even extend the same secure services over a wide area network to remote offices or branches with encryption as an option. Fabric Connect is a core building block of the infinite enterprise, helping us bring an effortless experience to our customers. The legacy network has been a very complex environment, often with rigid topology requirements. You know, we even use different networking protocols in different areas, and security seemed to be an afterthought. Fast forward to Fabric Connect. First, we create a standards-based Ethernet switching fabric. That's a set it and forget it type of configuration that forms a fabric with no topology dependencies. The services layer is abstracted. These segregated services are called virtual services networks, or VSNs for short, which are easily created and extended by what we call edge-only provisioning. We configure the fabric node where the service starts, and the fabric node or nodes where the service ends using a global parameter called an ISID, or Independent Service Identifier, that creates a unique VSN. So how do we get here? You know, we realized early on that the shaky stack of networking protocols of the past was like building a house of cards. There had to be a better path forward. For the legacy network to recover from a link or node failure, we start at the bottom of the protocol stack and work our way up, reconverging one protocol at a time, which takes quite a bit of time, especially with multicast routing protocols like PIM. We help create a standards-based protocol called shortest path bridging, or SPB for short, with a top-down approach versus a bottom-up approach with traditional protocols. SPB replaces the legacy networking protocols with only one protocol and one control plane that provides sub-second recovery for any services if resiliency was designed in the network. The Fabric Connect network reconverges so fast that applications don't recognize the failure occurred. That means your users won't know, which keeps them very happy. The legacy network was originally designed as a shared resource. So if we wanted to provide an isolated service for something like video surveillance, for example, it was typically done on a separate network. Or we'd create a VLAN and extend it throughout the network with VLAN tagging, which means we literally touched every node and every link along all the potential paths. With Fabric Connect, we configure VSNs that are communities of interest that are isolated by default. These VSNs pass like ships in the night across the fabric. Jake will walk us through the types of VSN in his whiteboard session. We've discussed how easy it is to create and extend these secure VSNs, and the SPB standard allows for up to 16 million of these services. You know, because we build a network with Ethernet, not with IP, the network looks like a single hop from an IP perspective. It's actually one hop into the fabric and one hop out of the fabric. That means that the core of your network can be hidden from an IP perspective. And the old adage is, you can't hack what you can't see. That's what we mean by stealth networking topology. We can automate the access layer configuration by leveraging Fabric Attach, which provides service elasticity to authenticated users and devices. When authenticated with network access control, we automatically configure that service from the fabric and extend it to the access layer. When the user or device disconnects, we delete that service and retract it to minimize the attack surface. Fabric Attach is supported across most of our current switching and AP portfolios, and similar automation is available if we extend Fabric Connect all the way to the access layer. Network policies can be written and enforced based upon many parameters and helps create a zero trust environment for access. To summarize, Fabric Connect allows the IT department to simply say yes, stand up new secure services in minutes versus hours or days, and often without touching the core switches. Fabric Connect provides operational efficiencies and automation that gives network engineers more time to focus on strategic initiatives versus just keeping the lights on. We didn't touch much today on multicast, but we've greatly simplified and bolstered multicast routing without causing a heavy CPU burden like legacy PIM protocols. Fabric Connect helps create a secure networking environment that reduces your risk greatly, even with the proliferation of unsecure IoT devices. Fabric Connect is still Ethernet and IP based, so integration into existing networks is not a problem. Fabric Connect enables the infinite enterprise and helps us create an effortless experience for our customers. Let's transition now to my colleague Jake Cook for a little deeper dive on the whiteboard. Thanks for attending Extreme Connect, and take it away, Jake.
Thanks very much, Chuck. That's a great introduction to the benefits of Fabric Connect and a little bit of how it works. I'm going to walk you guys through the whiteboard session on how it works more at a technical level, and we're going to map those to the business cases that it solves. So we're going to do a little bit of technical, a little bit of business case, and I'm going to sort of translate as I go. So I don't want to get too technical, but I want to get technical enough so that people that are network engineers can feel happy that it's not architecture, and people that are business folks can see the benefits in real time. So what do I have here? I got my whiteboard set up, and I've got Fabric Connect on this side, and I've got the legacy architecture on this side. So I'm going to kind of bounce between both of these, but we found that it's really helpful to show people, hey, this is a standard. This is still Ethernet and IP. It's still routing. It's everything that you understood from the legacy world, except it's fixed Ethernet. Fabric Connect, 802.1aq standard is what Fabric Connect is based on, fixes the problems inherent in Ethernet. I'm going to walk you through how, but just to set the stage here, this is based on a lot of old architecture that took a long time to rein in and get a mastery of, and it's very complicated and complex to add and change. So all of those mistakes and problems that built upon on the past are essentially corrected here in this architecture. And that's why, as someone who came from a field background and installed networks, I wish I was using this. I would have more time back in my life. And I'm going to show you exactly why that is. So here is our access layer, or what we could say, some people like to say IDFs, access edge, if you will. We have our clients down here. And we have our core and distribution layers up here. And this is a very simple architecture, just for analogy purposes. Most networks don't really look like this, but these are the major nuts and bolts that we can use to articulate the differences between these two approaches for networking. Obviously, we have our firewalls up here. So again, Fabric Connect, Extreme Fabric Connect, which is the backbone of our Infinite Campus solution. And the reason we call it Infinite Campus is because you can take it anywhere and it does anything you really need it to do. It solves many, many use cases, again, with the same protocol versus the legacy approach. So I think that's where we'll start. If I have a legacy network and I just want to turn it on, okay, I haven't connected any of these devices yet. The first thing I want to call your attention to is that these are typically different devices, right? And they may even run different operating systems. So there's just a little bit of learning curve right there. So again, for people that are not network engineers and not used to that, that means I got to understand how this device works, and I got to understand how this device works just to get things turned on. I got to understand where these users are and who should not be allowed to talk to who or to what, right? So there's a lot of initial homework that you have to do in a legacy environment. Now, you definitely want to know that information before you turn up any network, but this will simplify that process, which is a major theme of this protocol. And the people who architected this protocol well over 10 years ago realized that these fundamental flaws were making the network slow to adapt, slow to change, easy to break, unsecure, right? Ethernet was created to be plug and play. And that was because we just wanted users to connect and start using the network. Security was an afterthought, as Chuck said. Well, with Ethernet, you have flood and learn, which basically means there's no coordination between the edge devices or any Ethernet switch in the network. They have their own forwarding table, and they flood and learn because they don't know where anybody else is. That's why they needed to create spanning tree, to create a way to stop loops, because a loop will break a network. Essentially, the translation here is, as this evolved, people realized, hey, plugging in the network's great, but the HR people are exposed to the financial people, and the other groups in the organization are able to access everything. So they had to start securing things. But then if the network went down, right, if there was an issue in the network and it broke access for everybody, Well, that's bad too, right? The point of a network is to work and move traffic and connect users. And if it's not working, then no one's working. So they had a conundrum. How do we add redundancy? How do we add security? So these are all bolt-ons. These are all evolutions, right? And again, we're going to see how this is simplified by one protocol, and this is the legacy approach. Build up from the bottom, but don't fix the underlying flaws. Flood and learn and the need for spanning tree. Spanning tree basically says, as I connect these devices in, I got to make sure I don't have a loop. And if I do have a loop because I want redundancy, like if this switch were to fail, I want the traffic to go the other way, this has to kick in and take over. And what it essentially does is it actually turns off an entirely good link. We can no longer use that link. So not only have I had to do a lot of homework and just figure out what the differences are in my architecture, because these are different things. These are different protocols that need to be added to this to just make it work. If we compare that over here, I have a one-time configuration. So this is a standards-based switch. So it can run all the same protocols, but we tell it the first time out of the box, hey, you're a Fabric Connect switch. And hey, these are your ports to other Fabric Connect switches. So I can do some really useful things, like connect any Fabric switch to any Fabric switch without worry of the topology. So I can build in redundancy right away. No, don't even worry about it. It's like plug it in, plug it in. If I have a Fabric switch to Fabric switch, use it, okay? Over here, I gotta be very careful. I might just break my network just trying to make it better. And that's why a lot of people got gun shy in classical networking worlds, and they didn't want to change the network. They didn't want to change and evolve because it meant they might have to work the weekend. And they might not get to see their kids. So let's go home and see our kids, right? Let's have a lot more time back in our day. And by the way, I can do this. Topology independence, that's what that means, because I have a control plane, ISIS, inside of Ethernet, keeping track of all of the forwarding tables. Here I have disconnected protocols that are layered upon each other that have to first work, and then the next one takes over. And then it has to figure out what's going on. Then the next one takes over. And again, that's just to form this network. So as I build this out, I can create a more robust topology right away. And I don't even have to do a full mesh, but I can. I don't have to follow a spine leaf architecture, but I can. And if I want to add a switch in the middle of the day, because there's a new trailer that just showed up and I got some contractors outside, do that. That would be very difficult to do here, and you might not be able to do it quickly. If I wanted to provision services, let's say the red user, that's supposed to be a user, green user, okay? We got these red and green users throughout the network. And as I connect in, right, I got my access layer, maybe I got some redundancy. Certainly I am not gonna connect that, right? That would cause a loop. I have some problems here. I've got to turn up my OSPF or my IP routing layer up here. I got to make sure that my PIM and my multicast are correct so that I can get my security cameras plugged in. And I have to understand how I'm going to do WAN connectivity. And I have to understand if I do want to do an IP fabric over the top of this, which is, by the way, how most other vendors implement this. They put all of this underneath of a VXLAN infrastructure, which is to say, build tunnels over the top. So again, most competitive approaches that are trying to accomplish this still use this underneath. So when you look under the hood, you see complexity. They might say, hey, it's simple to deploy because you hit that button and some server that you had to buy just configures everything for you. And that's all well and good. But when that breaks, and it invariably will, everything has issues and you need to troubleshoot it. Well, this is complicated. Just looking at this, I gotta know a lot more stuff compared to over here. But this still accomplishes everything I need and more. So why wouldn't I try to simplify what I have to know as a network engineer or an operator? I understand that I need a control plane and it's turned on automatically. When I tell this switch, you're a fabric switch, and these are the ports that connect to other fabric switches. The ISIS control plane, which is a routing protocol that's pushed down into Ethernet. And again, sorry for the non-network engineers out there, but that basically means this intelligence pushed into this layer, therefore absolving all of this stuff and condensing all of that functionality that you need into one single control plane. One thing to learn, one thing to understand, okay? So again, as we build this topology out, I gotta have a lot of stuff figured out just to get my users connected securely, safely, and redundantly. So if I wanna provision a connection from this red user to this red user, if I'm doing just a layer 2 extension, I gotta provision here, provision here, provision here, but I didn't even have redundancy. And if somebody else provisions this side of the network, and I get up to here and I see, oh, he already used that VLAN. Shoot, I got to walk that back. Then I got to call the guy that manages that side, and we got to fix it. So we got to coordinate a lot more. Here, because of this single control plane connecting all of the switches, I can look at this switch and I can know what services are provisioned in my network. And speaking of provision that service, if I connect that red user, I say, I want you to be able to talk to this red user. And let's say I just want a layer 2 VLAN stretch. I provision here and I provision here. And this guy takes over. Everything in the core of the network, the backbone of the network, is done automatically. And it finds the shortest path. Speaking of the shortest path, this acronym SPBM, shortest path bridging MAC and MAC encapsulation. Again, for the network engineers here, shortest path, just like Dijkstra's algorithm in routing. B for bridging, Ethernet-based fabric. M for MAC and MAC encapsulation, that's the data plane. The point here, the reason I'm spelling this acronym out is because all of the awesomeness is baked into that term. Again, single control plane and an encapsulated data plane. And that encapsulated data plane and being an Ethernet-based fabric means I don't have IP addresses in here for the end users to discover and trace, route, and ping. That means it's a security enhancement. Again, it's built into the protocol. Here, I need ACLs. If I just want to have a routed connection for the red network, I'm going to have to configure that right there, right there, right there. And then my green connection, same thing. I've got routing up here. So by default, this router is going to allow red to green talk to each other. If I didn't want that, I would have to layer in access control list, or I would have to, again, provision that VLAN all the way up to the firewall. And again, that's a manual provisioning. Here, I provision it one time, and I would provision it one time here, and I'm done. Okay, it doesn't matter if there's 2 switches in the middle or 200. It doesn't matter if these are on different continents because of this control plane connecting and coordinating everything. Again, simplifying and fixing Ethernet. Why layer in complexity just to do what we need to do in a network, connect our users together and allow them to share information? So if we provision a layer 2 interface, I have to do a lot of work here. If I provision a layer 3 interface, I got to do a lot of work here. I got to add security. Here, if I want to provision a layer 2 or a layer 3 interface, it's the same basic idea. I provision it at the edge and the rest of the network is provisioned for me. So I have all of my services, layer 1.5, layer 2, layer 3, and multicast, again, handled by this. So how does that compare with the multicast environment? An IP camera is a very good use case for multicast. Pretty much everybody has a need for video surveillance cameras. So as I connect this guy in, right, I got to make sure I got all this figured out right here. A lot of work right there. Over here, it's a single command, again, inside the fabric to turn on multicast, and this protocol handles it for me. So that means I have to provision here, and if I want the connectivity for my VMS, my video management system, maybe I got a little terminal display over here, and let's say we got a little terminal display over here. Same thing, video management system. If I plug this in and I want to use multicast, which you definitely do in your video surveillance deployments, that means I got to find my rendezvous points. I got to understand PIM. I got problems, right? So a quick story on that. I'm based in Vegas and I have some casino customers, 7,000 IP cameras. We replaced their cores with VSPs. By the way, we left their edge switches alone. They were still these third-party devices. And for the first time since they've built that network, they could adjust a fiber. They could reboot a core. And I'm watching a video wall with hundreds and hundreds of monitors, and I maybe saw a frame skip. That's because every single interaction that this is tracking fails over the same. So if I have a switch that falls off the map, everything fails over in 200 milliseconds. That's layer 1.5, that's layer 2, that's layer 3, and that is multicast. And again, translation there, faster recovery from problems. So fast, in fact, that I can actually do daytime maintenance. I can do a daytime add. I can add this switch in the middle of the day and not worry about taking my users down. If I want to do something like that over here, it's tough. And I may take the network down just to make the network better. So again, Fabric Connect, SPBM, shortest path bridging MAC and MAC encapsulation, is simplifying the network. Okay. We're making it secure by default. I don't have to layer in access lists because as soon as this user connects in, he is mapped or she is mapped to her Fabric service ID. ISID is what Chuck called it earlier, and that's the term for it. But in general, all you need to understand is that it's encapsulated through the infrastructure. So that means the intermediate switches, the intermediate routers have no knowledge of this MAC address or IP. Only the edge device needs to keep that state. Only the edge device has to keep track of who's connected to him. And then as it traverses the rest of the network, it's basically a service provider implementation at that point, automatically provisioned for me. The shortest path is automatically calculated for the green user. The shortest path is automatically calculated for the red user, okay? And if this switch falls off the map, everything traverses or reconverges in less than 200 milliseconds. These guys don't have any idea what happened. Well, it's assuming this guy had redundant connectivity over here, let's say. But if any of these core switches fails, it's the same thing. So that is built-in security. Here, I can ping and trace route through the network, which means I have an IP interface to go after as a hacker. Now, if I layer in ACLs, that's a valid approach to stopping that. We all know that in traditional networking, or I can force that traffic through the firewall. The point is, it's difficult to do. It's difficult to change. That's why this is so foundational. That's why this is a total reboot, a total rework of networking. But it's still networking. It's still Ethernet and IP. So people like me that did not come from this background can pick this up quickly. I've done many networks with this technology, and I've taught many network engineers that came from other vendors and went, oh, that's it? Oh yeah, I already understand all that. It's routing, it's Ethernet routing and IP switching combined in an elegant way to solve the problems of your network. And basically we're taking service provider level functionality, simplifying it and putting it out there for the enterprise to use. By the way, I have service provider customers that are using this as well. So it solves a broad set of use cases with a single protocol, a single rework. So I want to spend a minute here just talking about how we would extend this across a WAN infrastructure as well. I know I don't have that drawn out, but if I wanted to connect this network, let's say to this network, I can do so over the internet connectivity, and I can put a little fabric switch over there, put a tunnel through, that's fabric extend. Again, all the same switch, all the same OS. I don't need separate routers or separate devices running separate protocols. Everything is the same. So if I were in fact to do this and then to start migrating this poor customer to our Fabric Connect solution, I can extend my networks over the internet or over any WAN infrastructure. If it does Ethernet or IP, we can do it. Now I can create one logical network. So I can start to draw this as a service cloud. You saw that picture in Chuck's slide. That's what that means. That purple cloud and the services across it means I only provision at the endpoints. So I can abstract the middle details. I don't have to think about how is my network physically connected if I just want to connect this user to this user. If I want to connect this user to this user or multiple users, and I want to do so at a layer 3 implementation or layer 3 routing, I just turn it on at the edge the same way as everything else. Services are provisioned the same regardless of what they are. Here, everything is separate. Everything is sort of siloed and stacked up. Complicated, rigid, and unruly. I used to install these networks. I could tell you with a high degree of certainty, that's hard to do. Networking is still hard, but this simplifies it, okay? This is not going to replace your job either because a lot of the business folks don't understand half of the technical terms I just said, but they do understand 11 times faster provisioning, meaning if I have a business change that says, I got to add these video cameras, there's some new rule or regulation, I can do it that day most likely. Here, I have no idea how long that will take. I got to get into a lot of homework. A lot of people got to help out. I have statewide networks that run this, Department of Transportation networks. 3 guys take care of the whole thing, okay? So the power of this protocol, and it's still Ethernet and IP, it's networking fundamentals. Again, fixing the flaws in Ethernet. And when you start to layer in all of the other benefits that Extreme brings to the table, our total infinite campus solution, XIQ, Extreme Cloud IQ, our network management software that's cloud-based. XIQ SE, our site engine, right? This goes on premise, okay? This will manage third party. That means I can actually see these devices in my Extreme Cloud. That's pretty helpful, okay? So I can manage my entire infrastructure. And again, if I were to extend the fabric over here, I can step through and replace this network at its critical pieces. And if I wish to leave the edge alone, I can do so because Fabric Connect is standards based and we can implement with just about any network out there. So huge, huge benefits to any customer that needs networking. And if you look at how we've done and if you look at how Extreme has positioned itself, it's pretty smart actually. We have the easiest network infrastructure to implement, which is the backbone of our infinite campus solution. We can go across any WAN, and we have our management tools that can do third party because every network has a mix of devices. So we have everything that you would need to be successful in your business. And by the way, we meet you where you are. What do you want to do? Do you want to have this in the public cloud, the private cloud, or even on-premise? We give you that choice. If you need to be air-gapped and completely cut off from the cloud, we have that choice as well. And this all wraps into the network access control solution that we offer that allows you to not even have to automate, to provision here, right? It's not even that hard to provision these commands at the edge because I don't have to mess with anything in the middle, but we actually can allow you to securely and automatically do that as well when you combine it with our NAC solutions. And by the way, our NAC solutions will manage this infrastructure as well. So I can have one management suite. That is effortless networking in a way that it's never been done before. Again, fixing the problems of the past in an elegant way based on experience. So Extreme Fabric Connect, a foundational technology. I mean, simple, difficult, rigid. I mean, what more do we really need to say here, guys? Thank you for watching this video presentation. Thank you, Chuck, and thank you, Extreme Networks, for having this technology and allowing me to play with it and talk to you guys, which is the best part of the job. Thank you very much.